This is greater than that. That means what? It's somewhere above 4. So it's not choked. If it's not choked, ATH is not equal to A star. So how do I determine the back pressure of it? Remember, if it's an isotropic flow, which we assume here, okay, I did not write it down, but we assume it's an isotropic flow. So what you would do is your PE over PT will be equal to PB over PT. And this also is a very good statement for you to make, and you have to make. Because now, nowhere in your flow is supersonic. Your pressure can adjust to the surrounding pressure. So your pressure in the flow right at the exit is the same as in the ambient. That's what it says. Right? Of course, you can directly write PE equal to PB is equal to 450 kilopascal divided by 500 kilopascal. I mean, as a judge, I can give you a pass. But if you can write that, that is really fantastic. Because that conveys the idea that you know the flow is subsonic throughout and the flow is subsonic at the exit. So PE is the same as PT. Make sense? Now, what does PE mean? Let me really explain it. They say you are a molecule with a flow. You are a flow in the darkness. Huh? When you are at the exit, you yourself has a pressure. And the ambient has a pressure. They have to equal. Right? That's what I'm trying to say. So the pressure really is a flow property. Right? The pressure is related to the flow. Now, ambient air has a pressure, that's fine. Right? My flow property at the exit is the subsonic flow. The pressure has to adjust to the ambient. So that's what I mean. So this is 0.9. Right? So this will give you ME equal to 0.39. So that's different from that. And association P, right? It's kind of like you are comparing 4 with something about 4. Right? Make sense? So E, if PB over PT is less than 0.779, M dot equal to 1. Now, M dot is easy because you choke, right? Because MPH is equal to 1. So M dot, that means it's choke, is PT A star square root of gamma TT gamma A star ATH equal to A star here. You probably want to write before that. And then you will have gamma plus 1 over 2 to the power of gamma plus 1 divided by 2, 1 minus gamma. I trust you can plug in the number. And don't forget, R is 288 joules per kilogram per Kelvin in the SI unit. Right? You don't cancel the 0.288 kilojoule. You don't cancel the K with the kilograms K. Okay? Now, once you do this, you will find out this is 0.365 kilograms per second. Why don't you do that? Verify this number is true. Here and there, sometimes I make mistakes in terms of numbers. So it would be nice you repeat it and you know what is correct, what is wrong. Excuse me. Oh, I'm sorry. If this is less than that, yeah, you will find this is wrong. 0.505. Now, if this is the case, in this case, you can calculate the mass flow rate. Mass flow rate will be equal to rho E, VE, and E. Right? Let me redo that part, okay? So, part C, let me see. Part C, because ME is equal to 0.39, you can use table TE over TT is equal to 0.971. So that gives you TE is equal to 388.4 Kelvin. Your PE, PT, actually you really don't really need it because this is equal to PE over PT, right? So in a sense, you already know your PE is equal to 450 kilopascal, right? So M dot will be equal to rho EVE AE, which is PE RTE times ME square root of gamma RTE times AE. AE we already know, right? We calculated in part A, which is 5.88. So you plug this in there, this gives you the answer of 0.365 kilogram per second. So compared to the choke condition, of course, it's slightly less expected. Make sense? And I would add a small question here, which is not in your textbook. For perfect expansion, and ME equals 1.5, you have a PE over PT equal to 0.2724. So this will give you PE equal to 136.2 kilopascal. And this has to be equal to PB because you want a perfect expansion. That means there will be no shock wave and there will be no expansion wave outside and out. So that makes the flow perfect expansion. So this is like 0.5 on that graph. So we were able to calculate this condition, and one of these conditions, right? With this example. And we can calculate the mass flow rate when it's choked, and the mass flow rate when it's not choked, right? Make sense? Sounds good? Okay, if it sounds awkward, we should have a quiz.